Yes, welcome again to DC Economics. So I'm going to take you through conditional probability. For example, let A and B be the two events. The conditional probability of event A given that of B that has occurred is denoted by probability of A given B, which is equal to probability of A intersection B over probability of B, whereby probability of B is greater than 0. Similarly, the conditional probability of B given A as occurred is defined as a probability of B given A that is equal to probability of bracket A intersection B bracket over probability of A, provided that the probability of A is greater than 0, and whereby the probability on the upper above illustration, probability of B is greater than 0. So after understanding this, let's go quickly to example. For example, a hamburger chain found that 75% of all customers are mustard, 80% use ketchup, and 65% use both when ordering a hamburger. So what are the probabilities that A ketchup user uses mustard, B a mustard user uses ketchup? So simply what you need to understand from this kind of scenario problem, the first procedure we need to let out A to present out the customer that uses mustard, and let B represent that all customers uses ketchup. For that case, the probability of a ketchup user uses mustard is given by probability of A given B, whereby A represent out the customer uses mustard and B represent out the customers uses ketchup. So the probability of A given B is given by probability of A intersection B divided by probability of B. So we may ask ourselves, what is the probability of A intersection B? Let's consider to our scenario over there. So the probability of A intersection B is like to say, let's start to examine what is the probability of A. So the probability of A is that a burger chain found that 75% of all customers are mustard. So A represented customer uses mustard. So we take out 75% divided by the total number of sample space, that is 100, and the answer will be 0.75. But we need to find what the probability of B. B represents the customers uses ketchup. So when you refer to the above question, those who uses ketchup were 65%. So we take out 65% divided by 100. We take out 80%, not 65. We take out 80%. Those who uses masters were 80%. So we take out 80% divided by 100 is where we obtain out 0.80. But the probability of A intersection B, we consider the statement on the above question that those who uses both when ordering hamburger was 65%. So 65% uses both when ordering, so it will be 65% divided by 100. That will give you 0.65. So the probability of A intersection B is equal to 0.65. Let you now plug into a form of probability of A given B is equal to now 0.65 divided by 0.80, whereby 0.65 is a intersection B and the probability of B is 0.80. So when you divide, the answer will be equal to 0.8125, as you observe. So the answer will be probability of A given B is equal to 0.8125. So that is a probability, that is a required probability that the question requires to understand. So that is part A. We have found that the ketchup, the probability of a ketchup used as a method is 0.812, as you observe, 0.8125. Now let's find the probability of the part B. Part B, we require to solve out the probability of B given A whereby we find out all the probability of a master user sketcher. So when we find out the probability of A, we'll obtain, you take out probability of A given B given A is equal to 0.65 divided by 0.75. Since we have all the data of probability of A and B, when you divide out probability of B given A, is where you look out the intersection over there. So when you divide out, you obtain the answer is 0.75 as observed. So the probability of A given B, probability of B given A is equal to 0.86665. As we take out the probability of A and B, it's a matter of only dividing. So since we have all the probability of B intersection A, you have the probability of A, that is 0.75, and probability of B is equal to 0.8. When you plug into the form of probability of B given A, the answer will be equal to 0.75. So the question now, the question number 2, that is an example number 2. An individual is picked at random from a group of 52 athletes. Suppose that 26 of the athletes are female, of which 6 are swimmers. Also, there are 10 swimmers among male athletes. Now, required part A, given that the individual picked is a female, find the probability that she is a swimmer. Given that the individual picked is a female, find the probability that she is a swimmer. And part B, given that the individual is a swimmer, find the probability that he is a male. Now let's go to solution. In order we can find the part A, we can solve the part A that we're required to find the probability that she is a swimmer. Given that picked is a female, so let F represent out female, and let S represent out swimmers. So F represents female and S represents swimmers, as you can observe. Now let's find now the probability. Let's formulate what we are required to solve out. We are required to solve out the probability that she's a swimmer when the individual picked is a female. So probability that is the swimmer given female is given by probability of swimmer intersection female divided by the probability of female. Now, what is the probability? What is the probability of swimmer intersection female? Number of athletes were 52. Number of swimmers were 6. Female. We are required to find out what is the probability of S intersection F. That's swimmer intersection female. Now we refer to our question over there. The probability of, let's find first the probability of female. Probability of female is given by number of observation, number of events over number of sample space. Now we refer to the question probability of female. Since the females were 26, we divide by the total number of athletes, that is 52. We obtain the probability of F, that's of female, that is equal to 226 over 52. Now, what is the probability of swimmer given female? We need to find the probability of swimmer intersection female, S intersection F. Now, we refer to the question of 26 of the athletes are female, of which 6 are swimmers. So here the intersection between the swimmer and female is obtained to be 6. So 26 of the athletes are female, of which 6 are swimmers, as you can observe. Now, for that case, probability of a swimmer, probability of swimmer intersection female is equal to 6 divided by the total number of athletes, that is 52. So probability of swimmer intersection female is given by dividing 6 divided by 52. So we plug in divide by the probability of female, that is equal to 26 over 52. So when we plug into our formula, we'll obtain that probability of swimmer given female is equal to 6 over 52 divided by 26 over 52, that the answer will be equals to 3 over 13. So that is the probability of S given female. So the probability of swimmer given female is equal to 3 over 13. So that is part A answer. Now let's come to B. We require to solve out the probability that she's a male given that is a swimmer. The probability that we require to find out the probability that she's a male given a swimmer. So since we have obtained the answer part A, now let's go to part B. So to part B, we do the same as we did in part A. So we require to find out the probability of a swimmer given female. Now we need to ask ourselves what is the probability of swimmer and what the probability of female as well. If you remember, total number of females were 26 and swimmers were 6. But we need to find out the probability. So when we take out probability of M, that is male intersection swimmer, divided by the probability of a swimmer, we need to cross-check what is the probability of M intersection S, that is male intersection swimmer. So let's first find what is the probability of swimmer. Probability of swimmer, since the swimmers were 6 as you observe, the probability, what the probability of swimmer, this will be taken by taking out, we take out all the values of 6, we take out all the values and we, so since we need to find the probability of swimmer, we need to check out all the intersections between female and swimmers on the above question. So when you take probability of swimmer, this will give you 6 over 52 plus 10 over 52. Since the probability of the two intersections between female and swimmers and male and swimmers is equal to 4 over 13, as you observe. So the probability of swimmer is equal to 4 over 13, as you observe. So let's plug into our formula now. Let's find the probability of M intersection swimmer, then we plug into the formula. From our above scenario question, we observe 6 were swimmers. A female which of 6 were swimmers. Also, there are 10 swimmers among male athletes. So there were 10 swimmers among male athletes. That is the intersection between swimmers and male. So the intersection of swimmers and male is equal by taking 10 divided by the total number of athletes, or total number of sample space, that is 52. So the answer there would be 10 divided by 52 would exactly give you that the probability of male intersection swimmer is equal to, we take out 50 over 52 as observed. So that would be the probability of, so when we find out, we plug into our formula now, probability of M male given swimmer is given now by taking out probability of M intersection S, that is equal to, we take out the probability of M intersection S, that is male intersection swimmer, as we solved earlier, that is equal to 10 over 52 divided by the probability of male, that is given as 3 over 13. So probability of swimmer is 3 over 13. So when you divide, you will obtain the probability of M male given swimmers is equal to 5 over 8. So that is how we solve. So thank you for watching. I welcome you. Bye bye.